Good morning, students. Today's topic is chemical reactions of carbonyl compounds. Already we have discussed some chemical reaction, nucleophilic addition reaction. The nucleophilic addition reaction, first one is addition of sodium bisulfate, then addition of hydrogen cyanide, then addition of Grignard reagent, then addition of ammonia. The nucleophilic addition reaction followed by loss of water. Then we discuss the reaction with alcohols, and then reaction with ammonia derivative, then reaction with hydroxylamine, phenyletrazine and semicarbazole, etc. Okay. Today we discuss the reactions involving alkyl group. Okay, the reaction involving an alkyl group. The first one is aldol condensation. Aldol. Okay, aldol means an alcohol and aldehyde. The two functional groups is obtained is known as aldol. Okay, aldehydes undergo a reversible self addition in presence of dilute base to give condensation product, which is both an aldehyde and alcohol. So aldol means both aldehyde and alcohol. Aldehydes undergo a reversible self addition in presence of dilute base to give a condensation product, which is both an aldehyde and alcohol. This is called aldol, and the reaction is known as aldol condensation. So aldol reaction and aldol condensation means aldehydes undergo a reversible self addition in presence of dilute base to give condensation product, which is both an aldehyde and alcohol. This is called as aldol, and the reaction is known as aldol condensation. It proceeds by addition of one molecule of aldehyde to the carbonyl group of another. One molecule of aldehyde to the carbonyl group of another, with the simultaneous cleavage of carbon-hydrogen bond in a position. Thus, acetaldehyde, when warmed with the dilute sodium hydroxide, it gives beta-hydroxybutyraldehyde. Beta-hydroxybutyraldehyde, the another name is acetaldol. Okay, so two molecules of acetaldehyde CH3CHO is reacted when warmed with the dilute sodium hydroxide, the base OH minus, to form a product beta hydroxybutyraldehyde. Okay, when a mixture of different aldehyde, each possessing an alpha hydrogen, is treated with a base, four different aldol products are formed. Okay, when a mixture of in aldol condensation reaction, the same aldehydes are used, but in the crossed aldol condensation reaction, the different aldehyde is used. Okay, the two different aldehyde, each possessing an alpha hydrogen, is treated with a base. Four different aldol products are formed. In crossed aldol condensation, the different aldehydes are reacted. Then the four aldol products are formed. The two from condensation of the two aldehydes with like molecules, and two from condensation of two different aldehydes in two different ways. Okay. The four aldol product is obtained, or CH3 CH double bond O plus CH4 CHO. Then the OH minus is reacted with the base to form a crossed aldol product. Then or CH3 CH double bond O plus CH2 or CHO. Then OH minus to form a simple aldol is obtained. Then CH3 CH double bond O, CH2 or CHO. It is an OH minus. It is presented in base to form crossed aldol product. Then CH3 CH double bond O, CH3 CHO with reacted with the base to form simple aldol. Okay, so crossed aldol products, four aldol products are obtained. In ketones containing alpha hydrogen also undergo aldol condensation to a smaller extent than do aldehyde. This is presumably as a consequence of steric hindrance to the carbonyl addition. Thus, acetone in the presence of base would establish the following order, following equilibrium. Acetone CH3CO CH3 plus CH3 CH3CO CH3 reacted with base OH minus to form a product diacetone alcohol or 4-hydroxypentone 2-pentanone. It is an aldol product. Okay. Then aldol condensation is not confined to aldehydes alone but can also take place between an aldehyde and a ketone. So it is known as crossed aldol condensation. Thus, acetaldehyde and acetone condense in the presence of casein to form 4-hydroxypentane 2-one. So, one aldehyde and one ketone is added in the presence of potassium cyanide to form 4-hydroxypentane 2-one. Okay, acetaldehyde CH3CHO plus acetone CH3CO CH3 in the presence of potassium cyanide to form CH3CHOH CH3CO CH2CO CH3. So 4-hydroxypentane 2-one is obtained. Then dehydration of aldols. Sometimes the aldol products are stable enough to be isolated. In other cases, water may be lost spontaneously to form an unsaturated aldehyde or ketone. Okay, sometimes the aldol products are stable enough to be isolated. In other cases, water may be lost spontaneously to form unsaturated aldehyde or ketone. Acetaldol itself may undergo dehydration on warming or in the presence of an acid to form crotonaldehyde. Okay, acetaldol or aldol is heated to form crotonaldehyde. Similarly, diacetone alcohol or aldol of acetone, that means diacetyl alcohol, upon heating or in the presence of dilute mineral acid dehydrates to give mesityle oxides. Diacetone alcohol is heated to form mesityle oxide. Okay, mesityle oxide. The next reaction is halogenation. Aldehydes and ketones are readily halogenated, whereby the hydrogen atoms on the carbon next to the carbonyl group are readily prepared by chlorine, bromine, or iodine. So, aldehydes and ketones are readily halogenated, whereby the hydrogen atoms on the carbon next to the carbonyl group are readily replaced by chlorine, bromine, or iodine atom. Then aldehyde are CH3CHO plus chlorine Cl2 to form alpha chloroaldehyde. Then ketone is reacted with bromine to form alpha bromoketone. The acetaldehyde upon chlorination yields alpha chloroacetaldehyde. Then CH3ClCHO and acetone upon bromination gives bromoacetone CH3Br Okay. Then these reactions are halogenation. Aldehyde or ketone is halogenated to form alpha chloroaldehyde, then alpha bromoacetone. Okay. Then next, reactions of carbonyl compounds. Reduction of alcohol. Reduction to alcohols. The carbonyl group of aldehydes and ketone can be reduced to give a primary and secondary alcohol. The carbonyl group of aldehydes and ketones can be reduced to give a primary and a secondary alcohol respectively. This reaction can be carried with hydrogen in the presence of metal catalyst and a platinum, palladium, nickel or copper chromate. Okay, aldehyde RCHO, ketone RCOR plus hydrogen in the catalyst palladium, platinum catalyst to form primary alcohol. In aldehyde, it gives us primary alcohol, and the ketone, it gives us secondary alcohol. At present, chemical reducing agents such as lithium aluminum hydride LiAlH4 and sodium borohydride NaBH4 are extensively used for the reduction of carbonyl compounds. The lithium aluminum hydride and sodium borohydride are extensively used for the reduction of carbonyl compound. The structural formula is lithium aluminum hydride LiHAl3 or AlH4, Li plus AlH4, sodium Na plus borohydride, 4 molecules of hydrogen with boron. The hydride reagent is dissolved. The hydride reagent is dissolved in the appropriate solvent and its solution mixed with the sodium of the carbonyl compound. The reaction takes place in the short time at room temperature. Lithium aluminum hydride and lithium aluminum hydride solution is prepared in ether because it reacts with the water and alcohol much as Grignard reagent does. Then reactions of hydrocarbons. The carbonyl group of aldehydes and ketones may be reduced to methylene group. It yields hydrocarbon. The carbonyl group of aldehydes and ketones may be reduced to methylene group, yielding hydrocarbons. Aldehyde RC double bond OH plus hydrogen, 4 molecules of hydrogen to form alkane or CH3 plus H2. Then ketones RC double bond O or DAS plus 4 molecules of hydrogen gives alkane or CH2 or DAS plus H2. This is done by two general methods. First one is Clemmensen reduction, then second one is Wolff-Kishner reduction. Clemmensen reduction and Wolff-Kishner reduction. First of all, Clemmensen reduction was amalgamated zinc ZnHG and hydrochloric acid as the reducing agent. For illustration, acetone CH3C double bond O CH3 is reacted with zinc or mercury, amalgamated zinc or mercury plus HCl2 to gives propane CH3 CH2 CH3 plus tin chloride and H2 and mercury. Okay. Then Clemmensen reduction, acetone is reacted with the zinc or mercury with the hydrochloric acid as reducing agent to form a product propane. Then Wolff-Kishner reduction, it utilizes hydrazine NH2 as a reducing agent and a sodium chloride as a catalyst. In this method, hydrazine is a reducing agent and sodium chloride as catalyst. First, the aldehyde or ketone is converted into hydrazone, which is then heated with the sodium chloride, Na plus C2H5OH, sodium chloride to give the hydrocarbons. Okay. Acetaldehyde plus hydrazine NH2, 1 molecule of water removed, hydrazone is obtained. Then it is further heated to form ethane CH2, ethane is obtained. The next reaction is reduction to pinochle. Pinnacle-pinnacolone rearrangement, that is known as reduction of pinnacle. Ketones when reduced in neutral or alkaline medium. Ketones when reduced in neutral or alkaline medium form 1,2-diols or pinnacles. 1,2-diols or pinnacles. Thus the magnesium amalgam and water acetone is reduced as follows. Then ketone CH3C double bond ketone is ketones when reduced to neutral or alkaline medium. 2H neutral or alkaline medium magnesium. This is the magnesium amalgam and water magnesium amalgam is used as the catalyst. And then the acetone is reduced to form a product 2,3-dimethyl butane. 2,3-dimethyl butane. Okay. Then the next heading is oxidation reaction. Oxidation of carboxylic acid. Aldehydes are oxidized to the corresponding carboxylic acid. Ketones are oxidized with difficulty giving acids with a smaller manner of carbonyl compounds. This case with which the oxidation reaction takes place provided a simple method of distinguish between aldehydes and ketones. Okay. When oxidized with the usual strong oxidizing agent such as chromic acid and potassium permanganate and aldehyde, potassium permanganate are converted to carboxylic acid in good lead or CHO oxidized, then the product or COOH. The oxidation can also be achieved by using milder oxidants such as the solution of silver nitrate, alkaline solution of cupric ions, and the hydroxide is made soluble by complex formation either with the tartrate ions or with the citrate ions. Okay. Next reaction is Tollens reagent. It contains the soluble silver ammonia ion AgNH3 twice. The oxidation of aldehyde and aldehydes. The oxidation of aldehyde is accompanied with the reduction of silver and to metallic silver with a support which appears as a mirror under proper condition. Hence, the reaction is also called the silver mirror, the mirror test for aldehyde. AgNO3 plus 2NH3 gives AgNH3 2 times plus NO3 minus. So, the ketone or CHO ketone is reacted with 2AgNH3 twice plus then RCHO plus 2AgNH3 twice plus 3OH gives RCOOH and silver nitrate Ag plus 4NH3 plus 2H2. Then filling solution, it contains complex cupric ions and is prepared by adding filling A solution which contains copper sulfate to filling B solution which contains sodium hydroxide and Rachel salt, so sodium potassium tartrate. During the oxidation of aldehydes to acids, the cupric ions are reduced to cuprous ion, which are precipitated as red cuprous oxide. Okay, RCHO plus 2Cu plus 3OH gives RCOO minus plus 2Cu. So in this method, it contains complex cupric ion is prepared by adding filling A solution which contains copper sulfate and filling B solution which contains sodium hydroxide solution. The Rachel salt During the oxidation of aldehydes to acids to prepare ions are reduced to cuprous ion, which are precipitated as red cuprous oxide. Okay. Ketones are not oxidized by the above reagents, hence are used to distinguish between aldehydes and ketones. Ketones can, however, be oxidized under drastic condition, which involves the cleavage of carbon-carbon bond. Then, consequently, the acids then produced contain forever carbon atoms than the original ketones. When oxidized with acid potassium permanganate or hot chromic acid, the ketone molecules clears as the C single bond C bond to give a mixture of carboxylic acids. Carboxylic acid, okay. Two such bonds are protect and both are liable to attack, increasing the range of products. In if one of the four carbon atoms has fewer hydrogen atoms than the other than this is attacked preferentially. Then 2-butanone is reacted with KMnO4 or H plus. It boils to form an acidic acid. Okay. Then formation of dicarbonyl compounds, aldehydes and ketones also undergo a special oxidation reaction, which does not involve the cleavage of carbon-carbon bonds. So, selenium oxide (SeO2) conducts the methyl group, which is adjacent to the carbonyl group, to form a dicarbonyl compound. First of all, acetaldehyde is reacted with selenium oxide to form glyoxyl intermediate. For example, 2-butanone is reacted with selenium oxide to form C6H5CH2 C double bond to CH3 plus selenium oxide gives CH3 C double bond to CH3. That is butane dione or diacetyl. Butane dione or diacetyl. Okay, these are the chemical reactions of carbonyl compounds. Okay, students.